theory, second theory is come, that is Bronsted-Lowry concepts or conjugate acid-base concept. So according to this theory, acid, those substance which donate H plus ions to the solutions, and for base, those substance which accept H plus ions in the solution. So he talked about the relative concepts. So suppose if Hx plus B is there, then this is BH plus X minus. So and backward reaction is again occurring. So from Hx to X minus, and from B to BH. So acid means H plus donate, and base means H plus accept. So from Hx to H means Hx is there, X means H plus is donating. Here H plus, Hx was there and it is converting to X. If you go into the forward reactions, means H plus is donating. So this is acid, and from B to BH means one H is accepting, so H plus accepting. So this is base, H plus accept means base, so this is base. And similarly, if I say from X minus 2, if you come to the Hx, then what H plus is accepting, X is accepting H. So here H plus H accepting. So this is, so H plus accepting means base. So this is base. And similarly, from BH to I am going to B, means what H is donating. So BH was there, coming to B means H plus is donating. So H plus H donating. So this is acid. So he says that forward reaction this is acid and this is base, and backward reaction this is acid, this is base. So for this acid Hx, so this is its conjugate base. For this acid, this is for conjugate base, and for this base, this is its conjugate acid. So he talked that if acid is there, then it must have the conjugate base. So if I take the examples, like if you have the water plus take NH3, the reactions, then what happened? So this will become S3O plus this is become OH minus and NH4 plus. So for here, this water, what H plus is donating. So this is acid, and for here, from here to here, but this is H plus accepting, H plus accepting. So this is H plus accept means this. So H plus donating means acid, H plus accepting means base. So this is acid, this is base. And the same, if I take, now I will take with HCl and water. Same reactions happen. So here what happened? So in these reactions, HCl to H, this HCl is donating H, so H plus donating. So this is acid. So this is acid. Similarly, from H2O2, so this is accepting H plus. H2 is there, one extra H is coming, so water is accepting H plus. Accepting H plus. So this is base. So for one, H2O is acid, and for example 2, H2O is base. So for one case, H2O is acid, and for other case, the same H2O is base. So he talked that it is a relative concept. It depends on what other molecules is present with it. So for the case 1, H2O was acid, and for case 2, the same H2O is base. So we cannot say that a molecule is acid or base. That is depend on what the other molecules is present. And he talked about, that's why he talked about the relative concept. We say that something is acid or base in a relative way. So like other substances, what is present near to it, or other which substances is present with it. So depend on that whether it is acid or base. So he give this conjugate acid base pairs. So he says that conjugate acid base pair always conjugate acid base pairs always found. What says, suppose X is there, then its conjugate base must be there, so X minus must be there. And similarly, if I say H3O, then OH minus. So SH so he says that if acid is there, then its conjugate base must be there. So he talked this, that they always found in a acid base pair. So he talked, so he says H plus donate means acid, H plus accept means base, and he talked that it may be any mediums. For RNUs, he said that it only aqueous medium, but he says at any solvent met that has to be in any solvents, but that has to be that in a for acid H plus would done it, for base H plus would accept. And one more thing, that if H2 minus is given, then like we may observe that this is for this H plus, if you get, then for conjugate acid just H plus add, and for conjugate base H plus remove. So you see that only the difference between two conjugate acids, difference between conjugate acid base pair is H plus. So for if you want to get the conjugate acids, then just H plus add, and if you want to get conjugate base, then just H plus remove from that, then we will get conjugate acid. So we will solve some problems and examples in next class. So limitations of it necessary that he cannot explain about Fe, or you can say Na plus, Ha plus, essential for, and Fe3 plus. So these things he not able to explain. So next theory came, that is Lewis theory. So what Lewis theory says, for acid, those substances which accept a pair of electrons, and for base, those substances which able to donate a pair of electrons. So acids, we can say, which accept a pair of electrons. So positively charged species are like, say, Na plus, H plus, and like electron deficient molecules, electron deficient molecules, like if we say that that is famous, that is BF3, essential for, these are the electron deficient acids. And for base, which have the lone pair of electrons to donates, like H2O, Cl minus, F minus, these are all are Lewis bases, and these are the neutral. So here the lone pair will able to donate like NH3. So these are all Lewis base, and Lewis acid like positive charge like Na plus, H plus, and electron deficient molecules like BF3, BH3, AlCl3, BH3. So these all are Lewis acids, like they are electron deficient or octet incomplete species. So these are considered as Lewis acids. So he talked Lewis theory. It is actually a electronic concept, electronic concept theory. So what are the actual like if you say the reactions between Lewis acid and Lewis base, then if you say like if you say BF3 plus NH3, then what will give? So it will donate its pair of electrons, and this is called adduct formation occurs. So advantage of adduct formation, like if you are seeing that BF3, so its boiling point is around minus 99 degrees centigrade. That is, it almost in the gas form. And if you add the ether, so its boiling point is around 45 degrees centigrade. So when they will form a adduct to this lone pair and to this vacant orbitals, then what happened? 3 So when these adduct formations occur, so its boiling point it comes to around 200 degrees centigrade, so which is in a liquid form. So this is a gaseous form and we change into liquid form. So whenever you're doing putting a reactions, the reactants is in liquid form, then it is easy to carry the reactions or easy to carry or handle while doing reactions. And if reactants is gases, then it is little bit tough to carry the reaction. So this, which was in a gas forms, will convert into a liquids by doing adduct formations. So these are the some advantages of doing adduct formations. So these are the theories. They say what are acids, what are bases, and according to their concepts, some are considered as acids, some are considered as base. So next we will study the ionization constant. So we already studied that Ha, this is acid, so this will give H plus A minus. So at T equal to 0, suppose this is 1 molar is there, then this will be 0 0, and T equal to T equilibrium. So from here alpha has reduced, alpha has consumed, so 1 mole, so alpha will form. So if it says the K equilibrium, so you know that is product concentration divided by reactant concentration, alpha into alpha 1 minus alpha, or that is called, or I can say H plus A minus by HA. So this the K equilibrium for acid it called as Ka. The K equilibrium, if we are talking about of acids, then it is known as Ka, and this is for weaker acids. So for weaker acids, and why not for strong acids? So for strong acid, if it says HCl, then it is completely ionized to H plus and Cl minus. So here the dissociation constant, that is Ka, is very very large. So that's why we generally not talk about strong acids, because strong acid Ka will come as a very very large value, because this is completely ionized. So for weak electrolytes, we can say that Ka equal to H, concentration of product by concentration of reactants. Similarly, if we talk about and this Ka is directly proportional to concentration of H and concentration of so this Ka is directly proportional to concentration of H plus. So if concentration of H plus increases, then Ka value also increases. And similarly for base, we will talk only weak base. So suppose MOH I will talk about like MOH, then it's going to give M plus OH minus. So T equal to 0, so this is 1 molar is present, so no product has formed, and T equal to T equilibrium, so 1 minus alpha H consumed, then alpha H for. So for this also K equilibrium we write, then product concentrations divided by reactant concentrations. So here for base K equilibrium is considered as Kb. So Kb is directly proportional to OH minus concentration. So if OH minus concentration increases, then Kb increases. So if you compare the acidic strength between weak acids, then that Ka is directly proportional to H plus concentration. So if Ka is more, then H plus is more, or H plus is more, then Ka is more. Similarly, Kb is directly proportional to OH minus concentration. So if OH minus concentration is more, then Kb value is more. So if we give an example, let's say CH3COH and HCl. Let's say its values are given. 1 minute. Okay, CH3 value Kb is given, that is 1.7 into 10 raised to minus 5, and for HCl this is acid, so Ka value that is 1.7 10 raised to minus 5, and for HCl value is 4.9 into 10 raised to minus 10. So compare which is strong acids. Strong acid. So you know that if Ka is more, then H plus concentration will more, means more acid, more acidic. Similarly, if Kb is more, then OH minus concentration is more, means more basic, more basic. So if you check, then this value is more, then this will be more acidic. So CH3COH is more acidic than HCl. And next we will study that phosphorus dilution law.